Hello, my name is Imran Aslam. Today I bring another application called Centrifugal Compressor Performance Modeling application. First of all, I will explain the installation procedure of this application through using the setup file, and then later I will explain the main features and the working principle of this application. So let's start with the installation procedure using the setup file. So if you already have downloaded this application setup file from my website www.petrosoft.com, then you can simply double click on this application setup file. The application wizard will be launched. From the application wizard, upon selecting the appropriate language from the language section, you can simply press the OK button. It will take you to the license agreement window where selecting the appropriate option on the window and pressing the next button will take you to the information window. Again, press the next button. Here it will ask you to create a desktop shortcut of this application. Now it is always a good idea to create a desktop shortcut so that you can launch the application anytime in the future straight from your desktop. Now you can press the next button here. It will take you to the final step of the installation. Upon pressing the install button down below, the application will be installed on your computer within few seconds. Since I have already installed this application on my computer, I will not install the application again. Instead, I will cancel the installation utility package here and go to my desktop where I have already saved the desktop shortcut for this application. So on this desktop shortcut of the application, I will simply double click the shortcut. It will launch the application on the computer straight away. Now let's look at the menu bar option at the top. First of all, on the left hand side, the first menu tab is the file menu tab. Under the file menu tab, you will have further three menu options. The first option is a new option, which can be used to launch a new instance of the application. For example, if you have closed this application from this cancel button on the right hand side, now you can go back to the file menu tab, then press the new button. The application will be initiated, or the new instance of the application will be launched in front of you. Now the next option under the file menu tab is a save button. Pressing the save button will actually save the results of this application into the PDF file or a PDF format, which later you can print it out or use it anywhere as you like. The next option is the exit button. Upon pressing the exit button, you can close the application. The next option or the next menu tab is the about menu tab, where you can read the main information or a brief about the application and the developer. The next option or a third menu tab on the file menu bar is the help menu button. Pressing the help menu will actually launch the manual of the application. In that manual, you can read in detail description about each step, and with the pictorial representation of each and every step, and the details how to fill in the required information and how to run the application, all are explained in detail in the manual. This manual comes along with the setup file and can be accessed from the help menu tab. Now going back to the main application, the next tab on the file menu on the menu bar is a link to my website. When you press the link, it will take you to my website where you can look at or review more chemical engineering applications as you like. Now starting with the main features of the application, this application contains several different pages. The first page on the left hand side is the input page, which upon initiation of this application will be launched first of all. On this input page, that's where the user need to provide all the required information, and the remaining all other pages are containing the results of the application, which we will go in few seconds. On the on the input page, this page is further divided into multiple different sections, starting with the leftmost section, which is the input section related to the physical properties of the gas. So here the user need to provide in the physical properties of the gas for the rated conditions. Basically, for the rated condition means that at which the compressor were first developed or designed by the manufacturer. So this information or the base case condition can be pulled out or retrieved from the vendor's manual or the data sheet of the compressor. The very next section, which is parallel to the rating condition, is a site-based condition. This is the area or the field where the user need to provide the actual site-based condition of the gas at which the compressor is supposed to be running at the site. Moving forward, the user need to provide the efficiency in the efficiency field and the rated speed at the 100% load condition at which the compressor performance curve at the rated condition has been provided by the manufacturer or in the vendor's manual. Now the next section below the physical properties is the operating condition section. This section is the field where the user need to provide the actual site-based condition of the compressor at which the compressor is likely to operate at the site. So the first information is the required flow of the compressor, and the unit of measure of the flow can be selected from this given list from the drop down menu. The most common unit of measures which are normally used at the site are compiled and listed in the drop down menu over here. The user can select the unit of measures or unit of measure of the flow appropriately and then simply provide the flow value in the next field, in the required field of the required flow. Now the next field is the operating speed of the compressor at which the compressor is supposed to be running at the site, and down below further required information such as the surge flow, safety margin, suction side equipment volume, discharge side equipment volume, suction side pressure alarm low or pressure alarm high, temperature alarm high, and this kind of information user can provide it in the required field. Now if the gas is saturated, which it does most of the cases, then user can simply take in this checkbox over here, the mix, the saturated conditions of the gas, which is the molecular weight and the mole fraction of the water vapors in the gas can be calculated by the application by itself. Now moving to the next input section, on the right hand side of the page is the rated performance at the 100% speed load. So basically the user here needs to provide the complete envelope of the speed range at which the compressor is supposed to be running or designed by the manufacturer to operate within a safe envelope of the minimum and to the maximum speed. Generally the percentage of the speed load from the minimum to the maximum is normally provided by the vendor's manual or by the manufacturer. So again you can pull out this information of the minimum percentage load to the maximum percentage load of the speed and fill in the top field or a top section of the speed percentage from the straight from the user's or a vendor's manual. Whereas the corresponding speed in RPM will be calculated in the fields just below this percentage RPM field. Here the user does not need to provide this information manually. Instead, this information will be calculated by the application automatically, such as when the user provide the speed load at 100% RPM, the speed in RPM by the user manual. For example, if I change this value, here you can see the speed in RPM for this corresponding percentage speed will be automatically updated in the fields over here. As you can see, the user does not need to provide this information by themselves. It can be calculated automatically. Now the next section over here in the input section is basically related to the main process parameters or the performance curve parameters, which are the volumetric flow rate, polytropic head, pressure ratio, power, discharge temperature, discharge pressure, and mass flow rate of the compressor. So these important process parameters are those process parameters against which the performance curves of the compressor will be calculated and generated by this application. But first the user need to provide these process parameter or process variable values at the 100% load conditions based on the rated conditions given by the vendor's manual. Here normally the vendors are provided with only two basic information of the process parameters, which are the volumetric flow rate and the polytropic head, whereas the pressure ratio, power, discharge temperature, discharge pressure, and mass flow rate process curves or performance curves are not normally provided by the vendors in some cases. So if that is the case, then an option is provided in this application that the user can take in this check mark or a check boxes to calculate these important parameters automatically by the application. So the thermodynamic algorithms are already developed in this application where these important process variables are calculated by the application itself. So as a minimum, a user need to provide the two basic main information straight from the vendor's manual, which is related to the volumetric flow rate and the polytropic head for the base case condition of the compressor from the vendor's manual. Now for these two process parameters, user need to provide 7 different data set values from the performance curve or the data sheet. But as a minimum, user need to provide only 2 data set values to run the application efficiently. However, if the user provide maximum information up to the 7 data set values, then a larger or a bigger range or a full range of performance curve envelope will be generated by the application. So for the ease of the users, I have already filled in all the required information, or the input data is already pre-populated in the applications that will help the user to fill in or revise or update this information with a ease, and to understand what kind of information needs to go into the respective field over here. Now once all this information have been provided or filled in by the user, then the application is ready to run and calculate the missing information or the required data through this application. So now all this information is already filled in. I will simply go and press the calculate button down below in the calculation section over here. Once I press the calculate button, the calculation will be done immediately, and the results for all the required field or the missing fields will be calculated and populated in the respective fields, as you can see over here in the first page. And the message bar at the bottom will turn into green color with the caption OK on it, which means that the calculation have been done successfully and no error messages were found or any warning messages were found during the calculation. Now on this calculated results, a section, a summary of the operating condition results are already built into the main first section or our input section for the user to quickly review the results of the compressor for the 2 base case conditions. The first is the operating point at the site base condition, and the second set of information is related to the operating point at the rated condition or the OEM provided base case condition. So here again all the important parameters are calculated and populated in the respective fields over here. Now if for example user has provided any incorrect value in any of the required input field, for example if the user punch in any text value in the required field where the numeric data is supposed to be filled in, then by pressing the calculate button will actually stop the application from running further and give you an error message with the message bar turned red, showing that there is some incorrect or inappropriate input has provided by the user. Therefore the user can go back to the respective field of the input, change it to or update the value to the appropriate numeric data, and then again press the next button, calculate button, and the calculation will resume, and refresh the calculation again, and the results will be shown on the respective fields over here. Now there is a warning section or a warning messages section is provided on the input page also for as a summary or to summarize any warning messages that you will likely to get if you provide any values or the operating conditions are going beyond or below or exceeding the limits of the performance envelope or performance curve envelope. For example, at the moment no warning messages have been found. It means that the compressor operating point lying between the phase or the process curve or process or a performance parameter envelope. But if any point, if the user has provided any value of, especially for the flow, for example over here the flow of 65 million standard cubic feet per day is selected or provided by the user. If however I change this value to any other number, and now let's look at what happened if I press the calculate button. Now I press the calculate button already, the calculation have been done and the message bar is still green, which means that the calculations have been completely or successfully done. However, the user can see some warning messages appear in the warning section and labeled as a red font, which says that the compressor under surge at the side base condition. Also the compressor is under surge at the OEM base condition, which means that the compressor calculation is done. There is nothing wrong with the calculation. However, the application is warning the user that the operating condition or the side base condition of the compressor is pushing the compressor into the surge condition, which means that the compressor is now running under the surge flow or a surge condition. Now if I go quickly to the process performance curve graph, which I will explain in detail after this, to look at how it is representing this warning message on the graph. For that the user can go simply straight to the head curve. For example, here you can see the two graphs are shown. The first graph on the left hand side is the OEM rated base case condition graph or a performance curve chart between the flow and the polytropic head, and on the right hand side there is an actual flow, the side base condition flow versus head curve. Here you can see a little triangle on the OEM flow, which is marked as a green color. Small triangle is falling beyond or beyond the surge flow or a surge curve, which is shown as a dotted line over here on the left hand side of the performance curve. And again on the looking at the side base condition, the given flow of 44 million SCFD is also falling beyond the surge flow curve, which is shown as the dotted line on the performance rating or a performance curve, which means that the compressor is certainly under the surge flow condition. Now, going back to the input data section, revising this value to an appropriate number and then pressing the calculate button here will remove this warning message. Now again, no warning message is seen over here, which means that if I go again back to the head curve, now you can see this little operating point, which is represented by the triangle, is lying within the performance curve envelope of the compressor, which means that the compressor operating point is within this stone wall curve and the surge curve of the compressor. So the compressor is not under any surge flow or a stone wall flow condition at the moment, and it is running in the normal state. Also, when the compressor is running under the surge flow condition, I will change the value again. Here in the operating condition results, you can see at the down below, the compressor condition is also represented with the description saying that at the operating point at the side base condition is under surge. Also the operating point at the OEM condition is also under surge, and the anti-surge valve, the surge valve state is shown open at the moment, and the surge valve flow, the amount of flow, the volumetric flow rate, the actual flow rate of the gas passing through the surge valve is also calculated and shown in the respective field over here. Whereas if I revise this value again to provide the correct or updated flow rate and then press the calculate button, the warning messages will disappear, and if you look at the compressor condition, it will become normal again for both the state, and the surge valve state also become closed, and zero flow is showing through the surge valve, which means that the compressor is currently not under the surge flow condition. So this is pretty much a small demonstration of how this application can be used to predict or develop different set of conditions for your side-based performance of the compressor. Again, the main purpose of this demonstration is to describe the main feature of the application, not to go in much detail or technical information about the compressor operation and the engineering or the design parameters. That I can share it in some other video or demonstration. Now let's quickly look at the result pages. First page on the top left hand side is the OEM or the manufacturer's performance data. Now the performance data is tabulated or calculated for the entire speed range, starting from the minimum to the maximum RPM, and the surge curve and the stone wall curve tabulated data is also calculated and projected in this result page over here. Similar calculation has been done for the side base performance curve data. Again, the tabulated data or calculated data is shown in the respective field for the entire speed range. Also, going further to the performance curves, the first set of performance curve is the flow versus head curve, or the flow versus polytropic head curve is projected in the graphical representation under the head curve tab for both the OEM condition and the actual condition, as you can see. Again, the next performance curve is for the discharge pressure performance curve for the discharge pressure of the compressor, again for the OEM and the side base condition. Similarly, the same graphical representation is developed for the power curve. So all the power curve for the OEM and the actual side base condition is developed. And lastly, the temperature curve is also developed for the OEM and the actual flow condition of the compressor. Once you are okay with the results and the results are done, then you are ready to take the print or look at the print preview of the results. For that, the user can press this print preview button here. The results will be shown, and in the print preview dialog box, where the user can actually review the results by simply changing the page numbers. I will go and change the page where you can see all this information as I have explained and you have seen on the application are projected on the print preview window, which later you can print out into the PDF form or PDF file or print out through your printer anytime once you are okay with that. So once you are okay with all this information or the calculated results, you can simply close this print preview section, go to the print button, press the print button. A print dialog box will open up. Here there is an option, you can print out this result into the PDF file, or you can print it out via attached printer with your system. You can simply print the results and you can simply print the results. Once you print the results will be again printed in the PDF form and displayed like the PDF file over here. As you can see, I am going through the printed out results into the PDF form or PDF form file. The same action of printing can be done through the file menu tab. Under the file menu tab there is a save button. You can perform the same action through this save button as well. Hope you have liked the video. For more information on the chemical engineering application, for more informative chemical engineering applications, please visit my website www.petrosoft.com. See you with more videos. Until then, bye bye.